By looking at the APICS reference framework, we can see that the MRP procedure is followed by two parallel processes. In case of production orders, it asks those related to materials or components to be produced internally. The operations management team is in charge of operations scheduling, while in case of purchasing orders, namely related to buy components or materials, the purchasing department takes care of supplier scheduling and operative management. When scheduling suppliers, the purchasing department provides suppliers with schedules rather than individual purchase orders. A supplier scheduling system typically includes a general agreement, a contract, and a schedule extending in the future and updated with an agreed upon frequency, like, for instance, weekly. Main inputs of this phase are already released production orders, up-to-date information regarding the availability of both direct production resources and indirect production resources, such as toolings, quality control laboratory, handling devices, spaces, and so on. Information regarding strikes, absenteeism, machinery breakdowns, planned maintenance activities, and any other factors affecting actual production capacity. Real-time information on production advancement. Changes in customer requests or other external factors, such as the rescheduling of a delivery date. Degrees of freedom of scheduling phase concern the logic of production orders review and release, the dispatching and routing of production orders, the sequencing of production orders on each single machine, the possibility of preemption, i.e., stopping a production order after processing has started, workforce reorganization, and finally, the rescheduling of planned maintenance activities. Relevant characteristics of the scheduling phase. A production schedule is a plan with the highest detail both in terms of products, single part number and single processing phase, and production capacity, maximum precision down to the current state of each single machine or work center. For this reason, the planning horizon of scheduling seldom exceeds 1 or a few weeks. The planning period, depending on the way data are gathered from production, could be ranging from 1 day to a fraction of a shift. Depending on availability of real-time information and frequency of planned disruptions, the schedule could be updated up to several times in the same day. However, at least once a week. No matter whether it focuses on activities to be executed at internal production facilities or at the supplier's site, the output of the scheduling phase is the allocation of production or purchasing orders to available production resources. As already mentioned for the scheduling process, here also we have two different processes, namely production activities control and supplier performance management, depending on whether we are considering make or buy components. The effectiveness of both phases is heavily depending on the definition of key performance indicators, KPI, to measure and assess suppliers' performances, defining appropriate scorecards, typically focusing on such performances as delivery reliability, lead time, quality, and price, and implementing a process referred to as vendor rating, and on the way the trend of, say, KPIs is shared with suppliers, for instance, employing web-based tools. Production activities control and supplier performance management are control phases. Finally, closing the planning and control process by monitoring actual production and reporting to the planning system significant departures from plans. These phases are very simple from a logical point of view, yet sometimes they could be very complex to implement. When possible, automating the data collection process would make things easier, as operators often claim to be too busy to report the beginning and end of production in real time. In any case, paperless data collection through barcode readers or touch screens rather than check sheets will avoid typical problems such as operators overload, delay in inputting data, clerical errors, and so on, associated with paperwork. Relevant characteristic of production advancement control phase. In terms of products aggregation level, as for scheduling, the control is carried out with the maximum detail, single part number, and single processing phase. Planning horizon and planning period are not relevant, as production control is carried out ex post. Finally, the updating frequency is real-time, whenever it is required to give timely feedback to other planning phases. Otherwise, end of period, like for instance monthly reporting, would be enough for performance evaluation. In a nutshell, the description of the various stages of production planning and control process shown how they nest into a hierarchical structure, where the upstream stages have longer planning horizons and higher economic impact, while taking into account a smaller number of constraints and working in a more aggregated way. On the other hand, downstream phases are taking into account a larger and larger number of constraints, are working out plans with a deeper level of details, but work with a shorter time horizon and bear smaller economic impact.